binary search and fake coin problem. B.1, binary search, elimination. I already mentioned binary search several times before, and I think all of you know how to do binary search. So why here we spend a lot of time, 2 videos to discuss about the binary search. I want to talk about from a problem-solving point of view. Now, because we need to learn strategies, we need to learn good problem-solving methods. Here, elimination method. We used once before. Remember, find the minimum. That problem. In that problem, find the minimum of an array. We use that elimination method. Every time when we do one comparison, we eliminate one element. So that is the simplest elimination method. But this method is so useful, so we will use it many, many times. Yeah. So here we just want to use this view to understand binary search. All right, so let's start. Yeah. The problem number 12, search an ordered array. Special. Yeah, ordered array. Yeah. All right. Given an ordered array like this and a search key V, yeah. Question, how to find an index I such that V equals A of I? That's simple. Yeah. The question is pretty simple. Yeah. Binary search, but we want to understand from the problem-solving point of view. Yeah. Not just solve this one. We try to get some general thinking, general way for the analysis. All right. Idea. Yeah. Idea. We used this idea many times before. It's called reduce the problem size by the ordered data property. We reduce the problem size. If we can reduce the problem size, we can make the problem simpler, smaller, and finally, we solve it easily. So that's the idea. But how do you reduce the problem size? Right? Implementation. How do you implement this idea? The strategy. Okay, the strategy. We can treat it as a strategy because we want to take advantage of ordered data property. Remember, ordered data helps us a lot. Let's recall the element uniqueness problem. In element uniqueness problem, we use 2 methods. The second way, we sort array first. Then we determine if an element is repeated or not. So you can see we spend a lot of comparisons to sort original array. But here we are given ordered array. So we do not need to sort it. We need to take advantage of the sorted array. Yeah. All right. Implementation method, we use the elimination method. Yeah. So next, we will get more details. How can we take advantage of ordered data property? Yeah, more specifically, yeah, we want to explore the ordering property. Yeah. All right, so here I use simple diagram. Yeah. This is an ordered array. in this way, sorted in this way. Now the key. So we want to compare V with one of the elements in the ordered array. Okay? And we want to see which element do we compare first to get the best result or best situation. Yeah, because at this point it is not easy to describe the final solution. Still too early. Yeah, but best situation, right? Yeah, vague description. Yeah. All right. We have many different ways to compare. V compare the last element. V compare an element somewhere in the middle, and V compare with the first element. Which one is the best? You need to explain your idea, why it is the best, right? You want to explain it. Yeah. All right. So here, yeah. So we want to look at in this way. Yeah. All right. So first, the question, main question we want to ask after one comparison: how many elements can be eliminated? So that's the essence of the elimination method. How many elements can be eliminated? That's the first question. Then we try to go deeper. The more elements that can be eliminated, the better the method, right? The more elements that can be eliminated by one comparison, that should be the good way we take. Yeah, here. So let's try that. First, if we compare with the last element, then we will have two possibilities to be considered. The first one, the best case, that is V greater or equal to A sub n minus 1, then we get the result, right? We get a result. Yeah. Greater or equal. If equal, we find it. If greater than it, V cannot be found in the given array. Then we're done, right? Yeah. So that's the best case. Yeah. Then other cases, V strictly less than A sub n minus 1. Strictly less than that. Yeah. So basically these two cases we need to consider. Yeah. Now the question, which one we worry about, right? Which one we should worry about? Yeah. Here I like to mention that Murphy's law. I want to mention that Murphy's law. Okay. So what's the Murphy's law? Have you heard of that? Murphy's law. Okay. The Murphy's law uses one sentence to describe anything that can go wrong will go wrong. Anything that can go wrong will go wrong. What's the meaning of that? Okay? Yeah. So you can give your own interpretation based on your own experience. Here, I give my interpretation. So this law is, first, it's not a scientific law. So definitely it's not a scientific law. Okay? It's based on our personal experience. Even based on our personal experience, it is based on our psychological perception. Psychological perception. Okay? Yeah. Psychologically, when something that could go wrong, most of the time we feel, oh, we happen to get that really bad situation. That happened in our life many, many times. So that's why this Murphy's law gives us big impression. in psychology. Mainly in psychology. Okay? Yeah. All right. So here, anything that can go wrong, the wrong here we mean the worst case, right? Or worst case. Yeah. If it's not a worst case. Okay? Worst case. So that means we should worry about the worst case, not the best case. Best case, we do not worry about it. Okay? We like to have it. Okay? Yeah. But we should worry about the worst case. So we should worry about that case. All right? Yeah. So here you can see this conclusion, comparing with the last element, it's not good choice. Not good choice. Okay? Similarly, compared with the first one, not good choice. Yeah, because the worst case is very bad. We don't want to have that. Okay? We want to find the element, when we do comparison, the worst case is not that bad. The worst case is not that bad, right? So then, we take care of that, Murphy's Law situation. Murphy's Law situation. The worst case, even we need to deal with it. The worst case. But it's not too bad. That's the point. Now, last step. We need to make our decision. Last step. Strategy. To make a good choice. Balancing principle. In this situation, when we make our decision, we should make balanced way decision. The decision should reflect a balancing situation. So what do you mean, balancing here? Here, let me give you the meaning of this balancing thing. Balancing understanding. Compare the one right in the middle of the array. Yeah. Because if you do this kind of decision, here we call it the median of the array. Okay, median of the array. Yeah. All right. Yeah. Some students still ask me, what's the meaning of the median? Yeah. All right. When you sort the array, the element in the middle, so middle we define because when you have even number of elements, there are two elements in the middle. In that case, you take the left one, okay? Left median. Odd, you have no confusion, okay? Only one element in the middle, so you take that. Yeah. But that's based on the value, okay? Based on the value of the elements in array. Yeah. Because some students ask me, given an unordered array, the one in the middle position, do we call it median? No, we do not call it median. Position in the middle. Position in the middle. In an unordered array, it's not a median. Okay? Yeah. So we have to sort it. The value, if we look at the values, it is in the middle. Then we call it median. So that's the main difference. Yeah. Yeah. Because many students ask me questions like that. So here I explain it. All right. Next, every time you can throw away one half of the elements. The left half or the right half. You have two cases. You eliminate left half array or right half array. Either condition, either case, they're almost the same. So that means the worst case is not too bad. The worst case and a better case, worst case and a better case, almost the same. That's balanced away, right? That's very balanced. Worst case, better case, almost the same, very highly balanced, right? So that decision follows the balancing principle. So that's a good decision. Okay? Yeah. Later we will use this balancing principle many times. Okay. All right, so let me finish the introduction of binary search here. Yeah. All right.